All right, so in this section, like I said, we're going to be reviewing some basic factoring. Again, they call it basic because it's like the two main factoring techniques you learn in the very beginning. And the first thing that I asked is, what is the first thing you do when you factor? The answer to that would be to identify or find the greatest common factor. Okay? Now, the greatest common factor, in a way, kind of looks like this. If I were to write 2x squared plus 6x, and I ask you, look at those two terms. What do they have in common? What would you tell me they have in common? Like, what can I divide the numbers by? A 2, right? So they have a 2 in common. And do they have letters in common? Yeah, now the first term has how many x's? 2. And the second term has how many x's? 1. So how many do they have in common? Not 3, that's in total. But how many do they both share? So this one has x's and x. How many do they have in common? Just 1. So that's what I take out, right? Now, when you're factoring, you're going to put that number on the outside. You're going to put a parenthesis, at least when you're factoring using the GCF only, usually two-term factoring. Then you start asking yourself, okay, if I take away a 2x from 2x squared, what's left over? Say it again. Just an x, right? If I factor out a 2x from 6x, now just so you know, the word factor, I don't know if they ever told you, but the word factor means to divide. Okay, I'll write that down right here. I mean, that's something they should have told you a long time ago, but in case they did not, to factor means to divide. In other words, if you factor out a 2 from 6, what you're really doing is dividing 6 by 2. What's 6 divided by 2? 3. And then if I take an x away from 6x, is it still there? No, it's gone. So here's my final answer, okay? This is my factored form of 2x squared plus 6x. Okay? I look to see what they have in common. If they have numbers in common, I divide them. If they have letters in common, then I just kind of say, okay, I have 3 of them here. I'm taking out 1. So how many are left, right? So we'll do more of these right now. We'll do 2 more of these examples. This is not a homework problem, what I just did. This was just more of a quick example. Okay? But here's a homework problem with only the GCF. Only the greatest common factor. Now, remember, this is the first thing you try all the time. No matter what kind of problem you're given, you might want to try to take out whatever numbers they have in common, whatever letters they have in common first, because that usually makes the problems easier. So we're going to factor, and here's part A. We'll do 2p squared plus 10. This is a homework problem. So we're going to do one that's kind of easier, one that's kind of on the harder side, and then we move on to the X method, okay? And if you want to see more of these, I can do more, and then we can move on after, but... All right, so you see this, it says 2p squared. So what I always do is I ask myself, do they have numbers in common? In other words, is there a number that can divide both 2 and 10? Yeah, what number is that? 2, so I'm going to write 2. Do they have letters in common? No, one of them has a p squared, but the other one has nothing. So they don't have any letters in common. So then I'm going to do this. All right? Now, you start with 2p squared. You're going to do both terms. All right? 2p squared. You factored out a 2. That means you divided 2, this 2, by that 2. What is 2 divided by 2? 1. And then all you have left is p squared, because you're not going to do anything with the letter, plus, now you're going to get 10 and divide it by 2. What does that give you? 5. So your final answer is just 2p squared plus 5. So there you go. That one's factored. Now let's look at part B. This is another homework problem. Negative 6n to the 6th plus 4n cubed plus 4n. I know it looks a lot more complicated, but remember, we're just going to be asking ourselves what numbers can divide this and what letters do they have in common. Okay? So what number divides negative 6, a 4, and another 4? A 2, right? Now some people, I'll do this at the end, but some people will actually say, let's factor out a negative 2 because I don't like the fact that there's a negative in the front. That's actually what I do, but I'll show you how you can take care of that later. Okay? But let's take out a 2. Now, I have, for the first term, I have 6 n's, right? N to the 6th. The second term has 3 n's, and the last term only has 1. So how many do they have in common? Just 1, right? Because one has 6 of them, one has 4 of them. Actually, that's 4 right there. Sorry, 3 of them. I was right with my numbers. 3 of them. And then the other one has 1. So they have 1 in common, right? So I'm going to take an n out. I'm going to leave some space there. Okay. Factoring means to divide. So what's negative 6 divided by 2? Negative 3, right? Yeah, negative 3. And if I take one n away from 6 of them, how many are left? 5. So it's n to the 5th. Plus 4 divided by 2, right? I'm factoring 4 by 2. So 4 divided by 2, that's 2. And if I take one n away from n cubed, how many are left? N squared. All right? Last one, we have a plus here. 4 divided by 2 is 2. And n, if I take an n away from an n, do I have any n's left? No. So here's my answer. Now, I'm going to put or. Because a lot of people, they don't like to see that leading negative. So what they'll do is they'll factor out the negative. They'll throw it out to the front. So it'll look like this, negative 2n. And every sign on the inside will change. It becomes 3n to the 5th minus 2n squared minus 2. And this is usually the answer you see most people write down in books, on answer keys and stuff like that. Because they don't like to see that negative in the parenthesis, just kind of in the front. So they take it out, they factor it out as well. Okay? It switches positives to negatives and negatives to positives. So that's what it does. So, any questions on these? So this is just basically taking out the greatest common factor. You have 4 problems like that, okay? Numbers 2, 3, 4, and 5. We just did numbers 2 and 4 together, so you guys just have to do 3 and 5, okay? But just kind of ask yourself, what do they have in common? What number can you divide by first? And then you ask yourself, what letter do they have in common? That way you can take those things out. Once you do that, then start factoring. Remember, factoring means to divide. So your numbers, you divide them. Okay, the letters, you can just kind of ask yourself, there's 5 of them here. I'm taking out 2. What happens? Okay. The outside number will be squared. Oh yeah, I was actually going to show you one little extra problem like that. So here's a little extra one that is not on your homework, okay? But if you had something like this, let's say you had 8n to the 4th minus, we'll say 4n to the 6th. And I told you to factor that. So you ask yourself, what number can divide 8 and 4? Now I know 2 does, right? But is there bigger than that? 4, right? I can take out a 4. Now, in terms of letters, the first term has 4 n's, the second term has 6 of them. How many do they have in common? 4 of them. So I'm going to take out n to the 4th. So that's to answer your question, can we ever have an n squared on the outside? Yeah, you can have anything on the outside depending what they have in common. So let's start doing the division. 8 divided by 4, that's 2. And if the first term had 4 n's and I take away 4 n's, how many are left? None. All right, minus. Now we do the numbers again. 4 divided by 4, that's 1, so I'm not going to write anything. N to the 6th is being factored by n to the 4th. So I'm taking away 4 of them from 6. How many are left? 2. So there we go, n squared. And that would be my answer for this factor. Again, this is not a homework problem, but it's just a question that was asked, so I'll show you what it can look like. Okay, you can take out more than just a single letter. You can take out multiple terms. Are we okay so far? So this is what we would call basic factoring. Okay, GCF is as easy as we can make it. After that, they require techniques. Okay, so we're going to move into one of those techniques, which is the X method, or box method for some. So here we go. I'm going to put this right here. The X method. Now this is going to look really weird and kind of complicated, but it isn't terrible. But just at first look, it can be kind of odd. Okay, so all right. What's supposed to happen is you're supposed to be given something that looks like this: ax squared plus bx plus c, and they're going to tell you need to factor it. Okay. So what you're going to do is you're going to create this x. Now on the top of the x, you're going to get your a times c. Whatever a is, whatever c is, you're going to put it at the very top. At the bottom, you're going to put your b value. Okay? Now here's the tough part. You're going to pick two numbers. Okay? You're going to pick two numbers. These two numbers need to, whatever your two numbers are, they need to multiply to whatever the top is. And they need to add up to whatever the bottom is. I know, it sounds kind of weird. Okay? It's not that bad, but it doesn't look nice. Okay? Some people call this the butterfly method because that's kind of what it looks like now, right? But it's just an x. You're going to get your a times c on top, your b on the bottom, then you're going to ask yourself, what two numbers multiply to the top and add to the bottom? Okay, and I'll show you that right now. All right? In certain situations, if you have an a term that's not a 1, okay, so if a is not equal to 1, then you must divide, oops, I misspelled that, divide the numbers by a. In other words, you'll get like the number that you picked divided by a for both of them. You're going to have to pick that, okay, the number divided by a. So we're gonna do a little bit of that, okay? Since this is a review of a lot of factors, there's a lot of little things that can happen. So I have to show you like what happens if this is true, what happens if that's true. So this is the X method, okay? So you multiply a times c, you put it on top, you get your b value, you put it on the bottom. Then you ask yourself, what two numbers multiply to a times c, or multiply to the top and add up to the bottom? Once you do that, you ask yourself, was a 1 or was it not? Because if it wasn't, then I got to divide that out. Okay? Once we do that, then we can write our factored form. So I'll show you guys how that all works. So let me give you examples here. We're still going to factor. So here's part A. M squared plus 2m minus 8. All right, so we're going to multiply a times c. Remember, this is a, b, c, right? We're going to multiply a times c. 1 times negative 8, that's negative 8. And then we're going to get our 2 value, and we're going to drop it to the bottom. Our b value goes down to the bottom. Now, Give me two numbers that multiply to negative 8, but when you add them, they add up to positive 2. So forget about the adding part. Two numbers that multiply to 8, or a 4 and a negative 2, positive 4, negative 2. Those multiply to negative 8. Do they add up to 2? Yeah. So I'm almost done with my factors. Do I have to divide? Well, let's see. A equals 1. According to what I told you, if A is not 1, then you have to divide. It is 1, so we're okay. I'm going to circle these. And here's my factor. M plus 4, M minus 2. And I'm done. You're going to use the letters that you're starting with. And then keep the symbols of the things that I circled. So M and a positive 4, M and a negative 2. And there you go. It's factored. Okay, we'll do another one like this. So we'll do part B here. And then we're going to kind of switch it up a little bit. So n squared plus 17n plus 72. Now I know sometimes those numbers get kind of big, so you're going to have to maybe use a calculator if you need to. So I'm going to just start off with my x. You'll notice again that your a term is a 1. That means I'm not going to have to divide at the end, okay? So 1 times 72 is 72. And then my b value goes on the bottom. That's 17. Now two numbers that multiply to 72 that add up to 17. 9 and 8. Positive 9, positive 8. Those add up to 17. They multiply to 72. Do I have to divide? No, because a is 1, so we're okay. I'm going to circle these, and here's my answer. N plus 9, N plus 8. And that's it.
So to get the first answer, we divide 8 to this.
Multiply. Yeah, to get the 72, it's A times C. To get the 17, it's just B. Whatever B is, you drop it. All right, now let's make it a little bit different here. Let's change things up. What if I did negative n squared plus 2n plus 15? So now A is no longer 1, right? A is negative 1. So that means I'm going to have to divide by negative 1 at the end. Okay, here's my A, my B, and my C. What do I put on the top? Which is what? Yeah, negative 15. What do I put on the bottom? 2. Two numbers that multiply to negative 15 that add up to 2. They can be positive or negative. 5 and a negative 3. That sounds good. Yeah, 5 and a negative 3. A positive 5 and a negative 3. Okay? Because 5 times negative 3 is negative 15. 5 minus 3 is 2. Now, I'm supposed to be like done, but I have to divide by A. So that comes out to negative 5 and a positive 3.
So that's not the difference.
Well, you can do that little piece. Now, when it comes down to this, you're supposed to basically take out, well, I guess you're supposed to leave it as your value, but you're going to factor it out this way. Let me write it out. So you're going to have n minus 5, n plus 3, and remember how there's a negative in the front? Just put it in the front. So this one's one of those kind of weird ones. Now I'm going to do one more, and if I can, I'll do another one because I know you guys have a lot of problems, so I'm trying to do as many as you can. So let's do some of these that look a little tougher here. 3x squared plus 13x plus 4. If I can do two more for you guys, that'd be good because then that means you have to do less. Okay? All right, what number do I put on top? 12. What number do I put on the bottom? 13. Okay? Two numbers that multiply to 12 that add up to 13. 1 and 12. Positive 1, positive 12. So normally I'm done, but my A term is not a 1, it's a 3, right? So I have to divide by 3. So this is still a positive 1/3. The right side becomes a positive 4. So to write my answer, it's x plus a third, x plus 4. But the thing is, they never want fractions there. So I always tell people, just take the bottom and move it up. So I always say bottoms up, right? You're going to get this number and throw it right in front of the x, inside of the parenthesis, okay? So it's going to look like this. 3x plus 1, x plus 4. And there you go. So if you have a fraction, you're going to get that denominator and you're going to throw it to the front. Okay? I'll do one more like this, one more of these like tougher problems. All right, now this will be part E, right? Now I know we already did a problem that had a negative in the front. I want to do another one and show you a little better technique as to how to deal with negatives. Okay? Now, this one, the reason why it's tougher is because there's a couple little things you can do. If they have a negative in the front, you can actually factor it out. You can take it out first. Okay? But do these also have a number in common? Is there something that divides 12, 24, and 9? Well, besides 1. 3. 3 divides it. So look, I'm going to take out a negative 3. And that's going to leave me with, they don't have any letters in common all the way through, so I can't take out a letter. This will be 4n squared minus 8n plus 3. And I'm only going to focus on factoring this. Only that. The negative 3 will still be there at the end with my answer, but I'm only going to focus on the thing inside. So what do I put on the top? Forget about the negative 3 for now. Well, just 12. Just 12. No need to multiply the ends. And what do I put on the bottom? Negative 8. I need two numbers that multiply to 12, but add up to negative 8. Say again?
Negative 2 times negative 6.
Negative 2 times negative 6. That's good. Negative 2, negative 6. Now, am I done or do I have to divide? Is there a number in front of the n squared term? Yeah, what's the number? No, in front of the n squared. Like directly in front. A 4, right? So dividing by 4, I got to divide by 4. What do I get? I get a negative half, right? That's if I simplify it. And this is a negative 3/2 if I simplify it. So here's my answer. I'm going to write negative 3 because it's still there. And then I got to write my solutions, okay? This will be n minus half n minus 3 halves. But can I have fractions in my answers? No, so I got to do that bottoms up twice, okay? The 2 goes there. This 2 goes here. So here's my final solution. Negative 3, 2n minus 1, 2n minus 3. And that's my answer. Like, that's probably the hardest question on the homework. There's another one that's very similar, but it doesn't have a negative in front. Okay?